Bill. My name's Nick Rice, Regional Manager, First 5 Minutes, South Australia, Western Australia, Northern Territory. And today we're going to talk to you about the history of the National Construction Code, formerly the Building Code of Australia, and Eye for an Eye. The significant parts of the National Construction Code, that's we're concerned with fire safety. We're going to have a look at passive and active systems, which there's loads of in buildings. We're going to talk about fire doors and firewalls, and talk you through fire resistance levels, which is quite important in the building to get an understanding about you, be able to see where you can put mobility impaired people or people who require help during an evacuation. Also help you get your personal evacuation plans together, personal emergency evacuation plans together. So the history of the National Construction Code, basically an eye for an eye. King Hamad in Babylon in 1758, he put some harsh penalties in place for builders. So if a builder built a house for a man and his work was not strong, and the house that he built kills the householder, the builder shall be slain, which 2,000 years ago, that means you will be killed yourself. It didn't actually, that law wasn't if he had built his own house for anyone in his family. After the Great Fire of London in 1666 and Chicago in 1871, building code started addressing adjacent buildings, roads, how narrow the streets were, the types of material which the building was made of, i.e. chimneys were made of wood, so they scrapped all that. They also put sanitary systems in place, and they put ventilation in place. Also, the roads wider so they could get firefighting equipment to buildings. So parts of the National Construction Code, which are mainly concerned with fire safety, is the general provisions, which is building classifications. There's all different classifications, up to 10, 1 to 10, and they've got subsections in them. That's section A. Section C is fire resistance and compartmentation and separation. That's what firewalls and your passive systems are normally concerned with. And section D is access and egress. That's your construction of exits and what have you, and that's all to do with fire resistance levels. And section E is your services and equipment, your active, mainly your active systems, so your smoke management, your lighting systems in your building, your automatic and manually operated alarm systems. And you've got another section there which applies to all your state and territories. The National Construction Code also refers you to certain Australian standards, and as I said last week, the Australian standards can lead you somewhere. You go into it, but it can change. So I'm not going to quote any particular parts of Australian standards. So all I'm giving you is information here, so you can go to the sections and you can have a look at what Australian standard which you're looking at. There's also, I've got on this call here, Nathan Brown and Alan Short. Nathan's the Managing Director of BC Engineers here in Adelaide, and Alan Short's the Managing Director of Fire Emergency Services South Australia, and he maintains fire protection equipment. At any time, if you want to know anything, you're quite welcome to go back in my emails, have a look, and email those guys, and they will be able to help you as far as they can. We've also, myself and Alan wrote a book together, and Nathan, Alan, and I have just recently published a new book. So building classifications, you've got 1 to 10, as I say. So you've got buildings 1A, which is your normal houses and things. You've got class 8, which is your factories and such like. Your buildings 9 to your healthcare facilities. All these different buildings require very different fire safety systems in them. So you might need, say, different travel distances. You might need for hospitals and places like that, where you've got high care and high dependency. Obviously, you're going to have a lot of fire doors and firewalls in there. So depending on what buildings you built, depends on what part of the building code engineers are looking at. Yeah, and that's about it on that one. So passive and active systems. Passive systems, they're part of the building structure. So that's things like your stairs, your fire doors, firewalls. Active systems, as I said earlier, they're automatic and manually operated fire control systems. So you've got your manual call points, your automatic systems like smoke detectors, you've got your sprinkler systems, you've got thermal detectors, you've got pressurization systems, you've got extraction systems, you've got all types of things in buildings which are sometimes automatically set off other bits and pieces, which we can go into as we're going through these sessions. So your passive systems, they're all your firewalls, fire doors, fire hazard properties, actual wall coverings and your floorings, etc., which have to be looked at every year. Compartmentation, so it's important you have your compartmentation right, otherwise you're not going to have safe areas in the building. And egress routes, so you could egress through one compartment into another. In the case of a hospital, you come out one compartment which has a firewall and then there's fire door. Shut that, if there's a fire in that ward, you can come out of that ward, shut the door, and you're into another compartment. And then you can go through other sets of doors, you can go into another compartment. And that's why in hospitals and things, in 4083, we do basically a 3-stage evacuation process. So it's not once the alarm goes off, you get out like in a normal office. You can go stage evacuation. So stage 1 is behind one set of doors, stage 2 is behind another set of doors, stage 3 is outside. Now by then, the fire service should be with you. So your active safety systems, loads of them in buildings, that's just a few there, which I just thought off the top of my head. You've got pressurization systems, you've got hose reels, you've got extraction systems, door release mechanisms, so you can have fire doors which are kept open all the time, and when the alarm goes off, they automatically close to give you that compartmentation. And that you see in hospitals and hotels mainly. Your sprinkler systems, you've got fire extinguishers, you've got hose reels. So a lot of these are manually and automatically operated. And like I said, we can go into those systems as we go through these training sessions. So let's talk about passive systems, your fire doors and firewalls. Now, they're regularly maintained throughout the year in accordance with AS 1851 and local regulations. Your local regulations could be anything like here in South Australia, you've got Minister Specifications 76, 2000, 2012 and 2015. And you've also got Part 59 logbook. So they have fire resistance properties that resist the travel of heat and flames from one compartment to another. Okay, so if you build a firewall around an emergency exit, then you need to get people into that emergency exit. So what you do is you put a hole in that firewall. So once you put a hole in that firewall, that's breached that compartmentation. So in order to bring it back up into line, you need to invent a fire door. Fire doors are very expensive, okay? And they have fire resistance levels just like your firewalls. And if you have a look there, fire safety door has on it, fire safety door, do not obstruct, do not keep open. It might say smoke door, do not obstruct, do not keep open. If you've noticed the handle, it's got to be able to be operated, one single hand, downward action and pushing. So downward push with no use of a lock or a key. You should be able to go into that fire stair and then it automatically shut behind you. So fire resistance levels explained. You've got your structural adequacy. So that's the ability to maintain a load bearing capacity. Okay, if there's a worst case scenario of fire. The integrity is the ability to resist the passage of flames and hot gases through that door. So you want it to not be falling apart. You also got the insulation factor, so it's maintain surface temperature. On the other side, then let's say you're in a fire stairwell and you've got worst case fire going on in the other compartment, you should be able to hold your hand against that door and it will not reach more than 60 degrees within a set amount of time. So it might be 90 minutes, it might be 120 minutes. And a way you can find out how those FRLs are on the doors and on your walls and on your frames, you have tags on, like this one here. And it will have an order, so I might say 61, 20, 90. So that means it can hold its structural accuracy for 60 minutes. It's got its integrity for 120 minutes, and it can be insulated against the worst scenario fire, being able to maintain the surface temperature on the other side below 60 degrees C for 90 minutes. In the case of a door, you won't have that first one of 60 because the door has got no structural adequacy to it. So you've also got fire and smoke seals. Smoke seals go around the frames of the door frames. You can see in hotels and hospitals, a lot of them are damaged through trolleys and things. So really they need changing because they should fully seal the gap. Some of them actually expand with heat, and they can withstand stand 2 to 3, 400 degrees C, maybe more in some cases. Depends on the manufacturer's instructions of which ones have been used. They can also be used for soundproofing and draft excluders. Now remember, I talked about last year about the passage of smoke, toxic. It kills about 80 to 85% of people. These smoke seals seal that door, seal that compartment. You've got your fire door got the structure, got the insulation factor to it, and then you've got the smoke seals. You're stopping that toxic gas getting into that compartment of where you are going to be, perhaps. Here you see several different ones I've done here. You've got automatic holding open device here. You normally see those in hospitals and hotels. So when the alarm goes off, bang, that door will shut automatically. It's held open with electromagnet. You've got smoke seals here. Here is one on order I did. There was a fire safety door here, and electricians have been in, and that door was totally blocked. The final egress door will open outwards. And that could stop thousands of people, hundreds of people getting out of the building. Here, the South Australian Metropolitan Service Fire Service guidelines is 006. Every state has guidelines from the fire service. I'd well recommend you all go and have a look at them because they can be quite helpful to you. So this one here, they require you to have green and white chevrons going down the door. If you notice, the arrows actually point to the door handle. So if you clammed up with smoke there, all you need to do is crawl on the floor. You can see that, and you can feel your way up, and you find the door handle at those arrows. And that's this EMFS guideline 006 for large isolated buildings and shopping centres in particular. I've been places, and if they're not large isolated buildings, and like here where the exits could be slightly obscured or hidden by a wall, you put the green and white stripes on there. I'd recommend maybe people go to the SMFS guideline 006 and think about putting the green and white stripes on the walls. This one's here in the hotel I recently stayed in. Quite fine. It's got the emergency exit light. You've got your fire door there. You know it's no use of a lock or key. One pushing action down, one action and pushing the door open, you get to the emergency exit. I'd always recommend when you go to a hotel that you check that door opens. As I've been to a couple of buildings before, and I've tried to get into exits when I've been doing training, and there's been a wedge which has been there to hold the door open, which can compromise life safety in itself, to being migrated to the other side of the door to stop people getting out of the building. Why accidentally, not deliberate, that could actually kill maybe a couple of hundred people on the floor, especially if the floor gets smoke filled. This one here's the fire door, which was in the basement of a hotel. And you could see the fire door's been penetrated with some handyman's come along, drilled holes in and put a new hinge on, which is totally against the building code and the Australian standards. And you can see there's a firewall there, that fire door, fire hinge set, because you've got the tag on it. If you want to know more about understand fire doors and fire ratings, you can go and look at this YouTube video, which is very interesting. It shows you how fire doors are made. You can see the intensity of the flames, hot gases, and heat trying to get through that fire door. So it will give you some confidence when you go into buildings and talk to people, maybe helping people with personal emergency evacuation plans, and giving them some confidence that that fire door has got a 60 rating to it, which means they're quite safe for an hour behind that fire door. It's not going to take the fire service an hour for you for them to be rescued. They're normally in the city, normally be with you within 5 to 6 minutes, I think is the average time. So next week, if you haven't got any questions, we're going to talk about different types of smoke detectors, how they work, and the best uses of smoke detectors. Okay, if you've got any questions, obviously feel free, email me. If you need any more in-depth questions, maybe on maintenance side of things, you can visit Alan Short, and anything more technical than that, like building engineering. If I can't answer the question, I go to Nathan and he will be able to answer the question for me. So if there's no more questions at all? No? You sure? Okay, thanks guys, we'll see you next week.